Good morning. In today's session, we are supposed to study about the linear predictive coding. In previous session, we have seen about the different types of modulation technique where we are supposed to transmit digital signal. How we are transmitting? We are doing the digital transmission, but here we are transmitting analog signal. We are converting that analog signal into a digital by using the modulation technique. In that, we have seen the different modulation technique like pulse code modulations, delta modulations, adaptive delta modulations, differential pulse code modulations. But we have seen all are having some advantages or some disadvantages. Like if you are talking about the pulse code modulation, it will transfer number of bits per sample. But if you see about the delta modulation adaptive, these are transmitting only 1 bit per sample. So here we can make our circuit implementation will be very simple as compared to the pulse code. But if you see, here is another disadvantage, like you will get the slope overload noise. Slope overload and granular noise will get present in the delta modulations. But if you are supposed to remove that noise, what we are doing? We are taking the improved version of delta modulations that we are talking as a adaptive delta modulations. So here, instead of keeping same step size, we are supposed to vary that step size. But due to which we will get their addition of a quantization error. So we can see this is the disadvantage of the adaptive delta. If you are talking about the differential pulse code modulations, here also you will get slope overload as well as the quantization noise, because here number of levels are fixed for the step size, but we can transmit the bits that can be more than or less than with compared to the pulse code modulations. So here now we can see about the linear predictive coding, which we are using in a audio signal processing. So we can say here, firstly we will see about the speech coding objective. It means what? Here we are supposed to reduce the bit rate. So here when we are transmitting the signal at that time, if you are supposed to reduce the number of bits, we are supposed to lower the bandwidth. It means what? Here we want to use the LPC, which we can use to transfer the audio signal. It is nothing but we can transfer speech. Speech is nothing but it is the audio signal. So here we are supposed to reduce the number of bits. So in short we can say here we want to reduce the bandwidth. So for that, if you see, we can see here block diagram, when we are doing the pulse code modulation, at that time we are supposed to do encoding, we are supposed to do sampling, we are supposed to do quantizing. It means what? You will get here encoded signal. That signal we are calling as a digital signal. But here we are supposed to reduce the bit rate of that digitized signal. So we can take that signal from a PCM and we can lower the bit rate by lowering the bandwidth. As you can see here, we will get here when we are using the PCM at that time, we will get the bandwidth that will be 64 kilobyte per second. But when we are supposed to use speech coding, at that time we are supposed to lower that bit rate up to 8 kilobit or a 13 kilobit per second. So here when we are talking about the voice speech, that can be a voice signal or a unvoiced signal. Voice signal, it means what? Which will be arises in the generation of vowels, latter portion of the some constant, and displays long-term repetitive patterns corresponding to the duration of the pitch interval, which will look like a pulse waveform. You can see the diagram for the pitch waveform. And unvoiced signal, it means what? Which will be arises in the pronunciation of a certain constant, like if we are saying like S, F, P, J, X, etc. It means what? Which will not get that much sound. So we can say its noise which will not get that much sound, we can say that as an unvoiced sound. And its noise waveform, it will look like this. You can see the waveform. The below diagram. So here now we are saying when we are supposed to use LPC, at that time we are taking the data from where? PCM. So what we are doing here, when we are supposed to use PCM, at that time we are supposed to follow Nyquist theorem. We are supposed to take analog signal as a input. So it will treat voice, means you can take voice, speech, that can be an analog signal, and it not use the properties of speech. It will take only that signal as an analog. After the PCM, what we will get? When we are using the PCM, you will get the digitized data. So you can take that digital signal and source model coding, or we can say that is we are saying as a O coding. So it will treat properties of speech to preserve our information. It means what? Here we are not supposed to lose information. We will negate that speech. But here we are supposed to reduce the bit rate. So we can use that, we can combine the waveform and source model coding in the linear predictive coding. You can see the block diagram for the linear predictive coder, or you can say the linear predictive coding. Here we are taking voice or the unvoiced signal. We are taking pitch extractor and we are supposed to give that to a transmitter. That is nothing but here we are supposed to use LPC transmitter. So here we are supposed to do encoding. So we can use here encoder, or you can say a mux. So you can see here the block diagram for the linear predictive coder, and we are saying linear predictive coder is a technique which we can use in the audio signal processing, in the speech signal processing. It has found particular can be used in a signal compression, because here we are supposed to compress the signal, but here we are not supposed to reduce our information. As we can use that LPC in many textbooks, it is taught in most advanced audio signal processing, because here when we are supposed to study about the LPC, we are saying here we are supposed to reduce only the bit rate. We are not supposed to reduce our audio information. So we can see here about the linear predictive coder.